Okay, let's start off by looking at the definition of a set. Set is any collection of objects. It's a very broad definition here. This does not have to be just numbers. You could have a set with Jake, John, and Larry, set with 3 items there, 3 elements. You could have a set with a blue car, a red car, and an orange car. You could have a set with the numbers 1, 2, 3, 4, 5, 6, 7. You could have a set with all of the numbers, all of the integers, which would be called an infinite set. It doesn't even have a specific number of items in it. So a set is really a broad definition there. It helps to start focusing in a little bit on what makes a set. Repeats are only counted once. So if I had a set with, let's say, the numbers 1, 2, 3, and 1, that set would only have 3 items. It would have the numbers 1, 2, and 3. If 1's appearing twice in the set, it's only counted as a single element in that set. And order of objects does not matter. So the set with Carly and Tim is the same as the set with Tim and Carly. And this part here, a well-defined set, is typically what we want to deal with in mathematics. And basically you just need to be able to know if you can put any element in the set or not. So if we had a set of all the people in finite math who are happy today, that's not well defined because we don't have a really good definition of what happy is. We could say a set is all the students in finite math who have sent a text message today, because for any given student in the class we could either say yes, they have sent a text message, or no, they haven't. So well-defined just means you need to be able to tell if any given element is part of the set or if it's not. Okay, let's talk about bag diagram now. So this is one way to visualize a set. It's very helpful to have visuals throughout mathematics, I think. And set theory is no exception. So we have this set named fruit, and we see the different items in it, the different elements. Let's take a look at what a bag diagram would be. So this overall, you can see it's kind of the shape of a bag. That's this overall set that we're talking about. This is fruit, and we can see the different items in it. So in it is apple, banana, and notice these brackets around apple, banana. What does that mean? It means this larger set fruit has, among other things, a small set with apple and banana in it. So we draw that as a second bag. Basically, wherever you see a set of curly braces, you're going to draw a bag. Notice that the next element of fruit does not have curly braces, apple, and we draw that by just drawing the apple in the bag, in the larger bag of fruit, without being in its own little bag. Now this right here, a bag with apple in it, is how we would represent this portion of the set. Notice that these are not duplicates. We said that sets don't have duplicates. An apple is different than a bag with an apple in it. You can kind of picture having a big grocery bag, and maybe you wrap the organic apple in a bag and the unorganic apple you just leave exposed. It's considered 2 different items inside your bag. And then finally we have this other bag with orange, grape, and jackfruit in it. So notice we do draw that bag there with these things in it. So what's the cardinality of the set? The bag diagram can help us with cardinality. Cardinality just means how many elements are in the set. What you don't want to do here is count, okay, we have apple, banana, orange, grape, jackfruit, so we have 5 things. That's not what you want to do. You want to look at the items as they're separated within the set. So this bag with an apple and a banana in it, that itself is just one element of fruit. It's kind of a package element of fruit. In fact, this entire thing right here, this bag here with orange, grape, and jackfruit, this is also just a single element. This is an element in the set, and this is an element. So if we count them, 1, 2, 3, 4. So the cardinality of this set fruit would be 4. So what's a subset? A subset is a set itself, and the way to tell whether some set is a subset of another set is to check every element of the proposed subset and see if every element is also one of the elements in the overall set. So for example, let's say if we're checking all three of these to see if they're subsets of this bigger set right here, this set fruit. Well, here, first of all, in order to be a subset, you have to be a set, and we can see here we do have a bag over the entire thing. So we do have a set here. So let's check it item by item. Is an apple one of the elements of this overall set fruit? It is. Notice not because of this, but because it's found right here. What about a set with an apple and a banana? That's the second element of this potential subset. And indeed, we find that bag with an apple and a banana up here in the overall set. What about this? A bag with an orange, grapes, and jackfruit in it. And in fact, we find that right there. Notice there was no bag with just an apple in it down here. That's okay. When we're checking to see if this is a subset of this, we're focusing all our attention down on this set, and we're just asking, is every element of this set also found in here? If there are leftovers, like there were here, that was something that didn't show up in the original set, then we can say not only is this a subset, it is a subset of fruit, but in fact it's a proper subset. So it's a little stronger condition even. What about this one? So here we have four elements in this subset. In this set, let's see if it's a subset of fruit. So we do have the apple up there. We do have the set with the apple and banana here. We have the set with the apple here. Do we see a set with an orange and a jackfruit in it? And only an orange and a jackfruit? We don't. We would have to find this exact element somewhere here in fruit without any extras in it. And this grapes kind of throws things off here. So this is not a subset of this overall set. What about this third one? So we do have a set, so it's potential that it's a subset of this. And we have to make sure that every element that we find in this set can also be found in the overall set of fruit. And bam, we're done. We didn't have to check anything because there are no elements in this set. It's called the empty set, and it's automatically a subset of any set. So this is a subset of fruit. Okay, so we got a bunch of symbols here. Let me go through. This means is an element of, is not an element of, is a proper subset of, is not a proper subset of, is a subset of, is not a subset of. I'm not going to focus on the not ones, just mean that the original one isn't true. So if something isn't an element of a set, then we would just use these symbols. So let me just focus on these three here and some examples. Okay, so we got rid of the jackfruit here. We have a set with four elements. The cardinality is 4. 1, 2, 3, 4. And we have true or false. The set containing apple and banana is an element of the overall set fruit. So is this bag with apple and banana in it, is that one of the items that we find in fruit? Indeed it is, so that would be true. What about this? Is there a bag with apple, banana, and orange in our overall set of fruit? Well, we do see an apple, and we see a banana, and we see an orange, but what we're really looking for is a bag that contains an apple, a banana, an orange, and nothing else. And we do not see there. So this would be false. Or if you wanted to, you could write this exact thing with a slash through the is an element of, and then the fruit. That would be a true statement. So if the original statement is false, you can make it true by just putting a slash right there. True or false, so now notice that this is the subset symbol. So in order to be a subset, it has to be a set, and it is. We have the brackets right here. Now we need to make sure that each element of this set can also be found in fruit. Well, first we look for apple. Can we find just a plain apple in our bag of fruit over here? And we can, it's right here. Then we look, do we find just a plain banana in our bag of fruit? And we don't. There is a banana there, but it's inside a bag and it's together with an apple. That's something different. In order for this to meet the condition, we would have to be able to find just a plain apple and just a plain banana. So this would be false. What about this? Is the set containing banana a subset of fruit? What is a set, which is a good thing? It's potential to be a subset. Now we need to check if banana all by itself is somewhere over here in this set, and it's not. So again, this is false. What about this? So is the set containing apple a subset of fruit? It is a set, so it has potential. So we need to be able to find just a plain apple in this set called fruit. And we do right here. Notice it's true because of this apple, not because of this apple. If we did not have this apple, let's say we eliminated this from the set, then this would be a false statement. But it is true because of this apple right there. Is the set containing apple? Now this is a proper subset. So notice it's very similar to the subset symbol, except it doesn't have that line. You can think of that line as being an equal sign. So this is proper subset or equal to, and this is just proper subset. It's kind of like less than or equal to and less than. It's very similar to that. So here we have a set, and apple is here. We find it with just an apple. In order to be a proper subset, the extra condition is there must be other leftover things that were not in this original set. And indeed we have 3 separate things left over, 3 separate elements, so this is a proper subset. Is fruit a subset of fruit? Well, they're both sets, and if you'd go through element by element of the 4 elements of fruit, you would find each of them in fruit, so the answer is true. In fact, any subset is a subset of itself. Now, it wouldn't be a proper subset because you don't have anything left over. Everything in this set is also an element in this set, but you wouldn't have any leftovers, so it would not be a proper subset. Okay, here we just have an empty set. You can think of an empty bag. It is a set, so it could be a subset. And in fact, as we said before, the empty subset is always going to be a subset of any other set. In fact, I almost said proper subset. An empty subset is almost always a proper subset of every set, with the example of the empty set itself. So the empty set would not be a proper subset of itself, but it would be a proper subset of everything else, and it'd be a subset of absolutely anything, including itself. Here we have banana, a set containing banana and apple as a subset, but we don't even have the banana to start with. The order doesn't matter here, whether it's apple banana or banana apple. That doesn't matter with sets, but we don't see a banana all by itself here, as we had looked at before. So it's false. Can you list the elements that are of one set but not another? So this set here would have this element with the 3 fruits in it, whereas this doesn't. This set here would have this element with just an orange and grape, whereas this doesn't. So neither one of them would be a subset of the other. And how to tell whether 2 sets are equal or equivalent? In order to be equal, the sets have to have exactly the same bag diagram. So these 2 sets would not be equal because this set has 3 fruits in it, and this set does not have those same 3 fruits in it. However, they are equivalent because they have the same number of elements. Both sets have 4 elements in them.